I'm Kevin Kakola. I've been working in the AI, LLM, machine learning, deep learning last few years. Currently, I'm also CMU Carnegie Mellon graduate researcher. I'm going to show you how I built a personal assistant voice agent using technologies, like a Pipecat and other libraries. Let's see. I'm actually before we do that, I'm going to make a live call to my agent, which I already built. You can see that. I'm going to call. Let's see if we can hear.
AI is machine learning engineer with 15+ years of experience. Currently focused on Gen AI, LLM, AI agents, RAG.
Okay. Tell me more about Kevin Kakola's education background.
Strong education background in blends business, AI, applied machine learning. Received an MBA at Sustain School of Business from 2012 to 2014. With coursework in
I'm actually going to interrupt. Tell me more about Kevin's tech stack.
Area today with testing is Gen AI and full stack
Okay.
AI.
Tell me whether in Pittsburgh. Yeah, actually, you see that? I was asking about Pittsburgh temperature and weather, but it told me where I'm located. Yeah, we have to fix that, I guess. Yeah, let's stop that. Okay, so let's see what are the libraries I'm using, and more importantly, the architecture which I'm going to use. So we're going to use the pipe card, as I mentioned. The architecture is based like this. As you can see, the end user makes a call uh, through actually Twilio, which is another library through which the the voice is actually converted through transport. You can see that you could use a Twilio, and then the converted from speech to text is actually used by Deepgram, and then that's sent to the LLM, large language model, whichever you can use, either OpenAI or Llama or Mistral, open source. And then you use another text to speech. I've used Cartesia. We could also use 11 Labs. And then the transport again, transport. So the pipe could basically transport in the form of forms, frames actually. Sorry about that. Yeah, you can see that. So this is basically, as you can see, the architecture. So I'm actually going to do the live. So let's create make directory. I'm going to call my agent GT voice agent. So before that, let me deactivate whatever the environment I have. So let me build fresh VNV virtual environment. The virtual environment basically localizes what are the libraries you're going to install to this environment so that not to pollute the rest of the environment. So now what? I already have the UV, so I'm going to install Pipecat. So let's do that. Okay, so this is the architecture. Let's do that. Yeah, I have a Python. So I'm going to install Pipecat. Okay, I already installed. So now I'm going to open the folder in VS Code, new window. Okay, so since I already have it, so let's do. So you have to create a file called bot. This is the entry point that through which um, the agent is actually invoked. So let's get the sample code from here. Yeah, so we need the environment variables. I'm going to copy the environment variables. So let me create env file. I already have the env variables. Let me collect all. Okay. So now, yeah, so once you have that, so we need some sample, like example code, which have they given. Let's try that. So I'm going to copy the code sample, which I already have it. So into bot. Okay. So let me walk through this code to see some of the imports. As you can see, the transport I was saying, you could use a Twilio is a library through which you make a call to the phone. It's more of a voice over IP, Twilio library. So you can make a phone call, and then Twilio will redirect your call to the our agent. And is another format, WebRTC, a real-time communication through web. Before connected to the Twilio, I was able to do the WebRTC. So when you go to the browser, you can still talk to the browser. Uh, and then so this is the prompt to my LLM. I'm just saying your chitty. That's my agent's pet name. Then you can see rest of the prompt. I'm just saying the Kevin Kakula's agent. Okay, we'll come back to the RAG processor a bit later. So this is the code which have the entry point. As I was saying earlier, the architecture. So Deepgram is a speech to uh, text. So this is the speech to text service. And then you have the Cartesia is basically text to speech. And then you have the LLM. As you can see, I'm using OpenAI LLM. You can actually use open source LLMs, but we can come back to that later. I found that OpenAI LLM is better in terms of the quality compared to the open source LLMs. Then basically context, and then this is the Silaro VAD, which is basically voice activation detection. As you know, when you speak on the phone, you can interrupt the agent so that agent stop talking. That's what it is basically. And again, RAG processor will come back to. And so Pipecat is basically orchestrator, meaning it's kind of line up the all the components which is using, for example, transport input. So basically, you take the input, which is the user talking, and then speech to text, and then aggregate the responses. RAG is will come back in a second. Retrieval augment generation. That is basically we have a very generic baseline LLM model, right? Which we are using OpenAI, I think 5.4, GPT 5.4. But the goal is to tell my agent about my CV, my tech stack, that kind of information. So how do you do that? It's it's not exactly fine tuning, but it's more of a fine tuning. You actually change the LLM weights and stuff like that. Whereas here on the top of the LLM, you are basically augmenting with additional information. That's basically retrieval augment generation. And then LLM is the OpenAI, and then TTS, text to speech. And then, of course, you transport and basically aggregate all. And then these are all, event based, as you can see. Uh, like you can see the events in Pipecat. So each, the information speech is transported as a frames. As you can see, uh, the pipe code actually basically transports as a frame. Um, that's what it is. And also pipeline task, right? So basically, you have this runner. Runner is basically we're actually using fast API runner. So that's how the pipecat actually runs. And then pipeline task, we're basically specifying the audio, um, sampling rate like 8,000 uh, probably hertz. I am not sure the unit, but that's what it is. And then enable the metrics, right? So when we deploy, you wanted to have some metrics. Um, and then this is again, RTV is again for the um, real-time communication. And of course, you're trying to do observer. And Whisker observer actually is not required, but I wanted to investigate, debug and see how the uh, this pipeline actually works as a part of debugging. That's why I had to do that. And this is actually entry point, as you can see. Yeah, you can see that Twilio is basically when you talk, Twilio takes the call and then converts into redirects to the LLM agent. That's what they does that. And then you can see fast API is under the hood. So pipeline actually, not the pipeline, Pipecat actually uses the fast API, as you know, which is one of the Python based backend server that actually runs. And more importantly, you can make multiple calls to the same agent, not just one. So it basically high availability, scalable. It's scalable. That's what it is. Yeah, so that's the code for the Pipecat, right? So let's run it actually. Um, since I already have the my agent, so let's do that. So give me run Python bot. So it's up and running, and it's up and running on 7860. This is to run locally, but also you can do deploy on Azure. You can see that. So I actually deployed here, as you can see if you click on that. So my bot is actually deployed, and you can see my Chitti voice entities is actually enabled. So the way I've done enabling is through web apps. You can go for web apps here. Before you do that, you have to uh, create a resource group, and then you have the you first you have to create the resource group, and then you create a resource. Yeah, you can see you can create a resource, and then uh, you can actually give the GitHub, and it'll pull from the GitHub directly. So this is my GitHub. I had the voice agent. Here it is. So this so you can give this link directly in the Azure, and it'll pull and deploy it. As you can see, this is my README file I was talking about. So it will a phone call goes to the deepgram speech translation, and then voice activation detection, and then GPT 4.1. I tried before 4.1. Now I have 5.4, and then Cartesia, which is the text to speech, and again Twilio is back to the caller. This is how the whole pipeline is actually built. These are some of the keys, and yeah, never mind this. This is just a default ID. Um, yep, that's how basically do that. So let's talk about the RAG. So what is RAG? So RAG is basically retrieval augment. Yeah, this sounds good. I'm looking for a diagram. Okay. So the retrieval augment generation. So I have the base model. So when I was asking about, tell me about Kevin's Coca-Cola tech stack. So you wanted to uh, train my model to with additional information, uh, which is about my CV and my the LinkedIn export and stuff like that. And then you send to the LLM so that LLM can respond back to that question. In this case, but other cases you can have a domain specific. Let's say we're working in healthcare, you can give the healthcare domain, or you want banking, you can give the um, your interest rates. In US they're called CDs. In Canada they call GICs. So there's a specific information to your bank. You can actually feed to LLM so that when the user asks about this information, LLM can respond. That's what it is. So let's get, and I've used actually more importantly Pinecone, which is one of the popular RAG database. It's a vector database, obviously RAG database. So I installed the Pinecone already. Quick start. Let's go to quick start. So there are two ways. Yeah, I can do UV add Pinecone or pip install. There are a few ways, and I have the API key already. So there are a few ways you can do in Pinecone. One way is you create a chat assistant that will basically abstracts all the inner workings of the RAG, like chunking strategies and how to chunk. The other way is to you do manually. So as a part of that, you create an index. Um, let's go, and of course, upsert and stuff like that. So let's go to the code. Actually, I did create a file called ingest. You can see here. So you can see the RAG database. So initialized. Yeah, NLTK is basically natural language. I think. Let's see what is. I forgot the convention. Natural language toolkit. Okay, awesome. So this is one of the, you know, tokenization. You can tokenize or chunking. So I've used in the past. So that's what I used. So NLTK, you can actually chunk it. So you can see the Pinecone, and then yeah, initially I did the assistant, chat assistant, but later it's not required. I mean, I replaced with the manual. As you can see, some prompt to the agent telling, then connect. So you create index and embedding. So obviously for the RAG, you need to specify the embedding model. I think we saw in this diagram, right? Yeah. So you need the embedding model. Obviously, this is Llama embedding model, open source, and then search query. So when you give the query you to the RAG database, it'll search this query, and it uses a cosine similarity, one of the technique where it's not exactly keyword matching. It's more of a cosine similar, like how close they are. Like for example, man and king are similar, queen and female or woman are similar. That's a very popular example. The literature talks about it. As you can see, chunk with NLTK. So I'm basically chunking. The upsert is basically insert, more of a replacing a file, upload and insert. That's how you can say that. As you can see, reading through PF. So I would basically given my CV here. Actually, I've given that, so you can actually uncomment that. The reason actually I did commented here is I've actually initialized only once down here, somewhere down. Yeah. So observe, yeah, insert basically my CV, and this is LinkedIn, export. So that's how this method is executed, and you can see chunking. So chunking is basically why do we need chunking? Chunking is splitting a document into small words. Generally, each LM has a context window. For example, these days I think GPT is in 1 million. I stopped counting or actually keeping track. So it's a context window, meaning there's only so much you can feed to the LLM at a single point of time. So for that reason, you have to chunk. Um, One of the chunking strategies, fixed chunking. So NLTK I'm using to chunk it, and then you can see this actually again used for the chart assistant, and you can search this here, and then this is just to test locally. So now you got the RAG. Then let's search for down. Yeah, so you can see. Uh, so the process frame, basically RAG processor is executed. In the RAG processor, you can see we're checking for the context frame and then search query, and then push to the RAG, and then yeah, we just only invoking because we don't want to invoke multiple times. Just if it is not already instantiated, just instantiate, um, and then fed to the LLM. As you can see, RAG processor. Yep. Yeah, so you can see as a part of pipeline, we're actually uh, one of the component in the pipeline is the RAG processor. So that way, we are feeding, you know, uh, the query plus the context coming from the RAG, and then fed to the LLM so that LLM can respond. That's what it is basically. And apart from that, I also have a evaluation. Let's see, test voice agent. So for the evaluation, actually, I've used what you call deep eval. This is a library or framework, whatever you call that. So to evaluate, meaning, so okay, we did. Okay, when we called the LLM, we asked about myself or any generic information, but how do we know how well the agent is performing in terms of accuracy or faithfulness and correctness and stuff like that? You can see there'll be some metrics here to eval metric. You can see here uh, some of the metrics. You can see. Uh, let's see the metrics. Should be somewhere here. Yeah. So these are some of the metrics for RAG, especially answer relevancy. So when the agent answers how relevant, let's say I ask about, I think you found that, right? When we did tested, I was asking about give me the weather in Pittsburgh or Toronto, the agent was talking, I'm based in Pittsburgh. So obviously, uh, it's not relevant. So you can see that, it has to be improved on. Faithfulness. So again, if I ask, what is the capital of, let's say, Canada, it should not tell you Toronto, right? It should be Ottawa, something like that. Again, contextual relevance. So these are the metrics. So I've used the deep eval. You can see I've asked basically prompt what is Kevin's experience with LLM. So given what is expected output and test case, and you compare, and you can see here assert and give me the score. I also specify, you can also specify threshold, zero point 0.3, zero point 0.4, whatever. If it is greater than, then you get the score one or pass. That's what it is. And uh, yeah, that's how you can actually evaluate. And I given three prompts. Uh, and I think if I remember correctly, you can do this deep eval test, and then you specify what is the file? Test voice agent. I see. Okay, I need to activate. Okay, let's see. Command I forgot. Mhm. Yeah, default test run. Okay, I interchange test run test. So it's running these evaluation test cases. Yep, it's running. These are all the my CV. It's just printing. I had some print statements. Bingo. There you go. You can see test cases coming up. While it does that, I'm going to see my GitHub repo. Yeah, this is the one. In case I'll share the link in the description, so you can take a look at that. And while it does that, let's see the test cases. Yep, it's taking some time. Yep. So some test case pass, some test case fail. Yeah, this is pass. That's good. So you can see the point 0.3 is pass, pass. Why it's failed? I see. So we given the point 0.3 as the threshold, meaning the response what I expected and what I got from the LLM is not exactly matching. That's why the score is only 0.37. There are a few ways to fix that. Either change the expected response so that it matches, or you can reduce the threshold. There are a few ways, you know. Yeah, I think that's about it. Very long technical explanation about this project, building a voice agent, using Pipecat, Cartesia, Deepgram, Silaro voice activation detection, and the actual LLM. And of course, evaluate through deep eval. And also, I've used the Pinecone RAG so that you basically fine tune the LLM with my specific information. Fine tune is not exact right word, but I kind of use interchangeably, loosely, meaning you kind of appending additional information on the top of LLM. I think that's about it. Bye.